Okay, cool. We are live. Hello, everybody. Today I am by myself, no guests. We're just hopping into building a rental place right away. So if you guys have not caught episode 2 of Web3 Unleashed, that's where we covered the ERC 4907 rentable NFT standard, where we interviewed Jesse from Double Protocol, who are the ones who created that standard. And so today we'll be taking that and actually putting into practice, building part 1 of Adapt. So just going over the smart contracts, not yet the front end. That will be coming in part 2. So I'm going to go ahead and share my screen so we can talk about the agenda. So here we go. Share. Cool. So, slideshow. Build an NFT rental marketplace part 1. Before we get started, I just want to say, shout out, please sign up for our email reminders and guides. If there is follow-up material, this is how I will be sending it over. You can either go through my beacons link, otherwise the QR code is up here. But let's get started with the agenda. So yeah, obviously we're always going to talk about project setup, just the usual suspects. Today we will be using Truffle plug and verify, which I will talk about later, but that's for actually interacting with already deployed contracts on, I guess, the Gurley testnet. We're going to add the rentable NFT to a full project, write the marketplace contract, obviously test it, test-driven development, number one thing. Go over that verify rentable or Truffle plug and verify. I'm going to introduce the concept of Truffle scripts, which is essentially allowing us to almost build kind of our own CLI for interacting with our marketplace contract very quickly without just doing a full test. For example, if you want to put real information rather than having that be torn down every time you run a test and end the test. Just gonna also touch on some debugging tips and tricks that I had to do. That's a little bit more advanced than what I've demonstrated before, just because this is a more complex tutorial. Leave some time for Q&A and talk about what's coming up next. So let's get started coding right away. So obviously we will be using Truffle. I am the Truffle developer evangelist. This time around, I've been demonstrating how to write and test your smart contracts using the Ganache UI. Today, we will be using the Ganache CLI, and this is specifically so we can take advantage of the more complex features that Ganache offers, specifically Ganache forking, as well as unlocking wallets. I'll touch upon that when we talk about verifying contracts, but yeah, this time download the CLI version. We will be using our Infura account. I haven't actually been using the Infura account in the previous tutorials. We finally are getting around it today because we're doing that verification. MetaMask to connect, plug and verify. I will be using VS Code. And you always need that test ETH to, I guess, test it on chain. Yeah, cool. So let us get started. So today, actually, the end goal of the rental marketplace app is to have a full front end as well as the smart contracts in the back. So previous tutorials, we've been just starting with a simple truffle init. But this time, we will be using our React box. So just to do that, React rental. Actually, let me just make sure I don't have rental marketplace already. Okay, cool. Yeah, I was just checking if I had already unboxed it because sometimes I do that and then it messes it up and you guys just see me, I don't know, mess up in the first place. So just to go over what truffle boxes are, they're essentially boilerplate / scaffold code to help you get started with popular use cases as fast as possible. So this will split up our code into contracts and client. Other example boxes that have come out is our optimism box. We are really focused on L2s at Truffle. I will actually be doing an optimism tutorial for DevCon if you guys will be there. But we'll get into that later. So, anyways, let's open up our marketplace app. Cool. Just going to briefly touch on the high level of what the box has. So it's the client section. Um, there is basically the way it's set up right now with the React box. It actually has kind of like a fake DApp that already does like the MetaMask wallet connection for you, as well as demonstrate how you would talk to your smart contracts in your front end. And then your Truffle side is going to be where your contracts are. This is where we're going to be working in. I specifically want to call out our Truffle config. So the difference here between Truffle init and Truffle config or Truffle unbox is it's changed the build directory. So when you compile those contracts, it creates basically a JSON file of the ABI, which is application binary interface, I think, which basically like defines all the inputs and methods on that contract. And in order to interact with that in our client, we need that to be accessible within our client folder. So the default behavior is usually to just create those JSON files in like a build at your top level directory. With the React box, we will be redirecting the build files into our client. So that's kind of the setup of the React box. We can go ahead and get started. So the first thing we're going to do actually is copy the what do you call it? Copy the rentable pets contracts into the rental marketplace. So the way I have this rental marketplace, I guess envisioned slash will be setting up is it's going to have three main functionalities. It's going to, as a user, you will be able to list NFTs. You will be able to view all the NFTs listed and then actually rent them. And then as the owner of the NFT, you also have the ability to unlist an NFT if you no longer want it to be rentable. The caveat here is that you can only rent, or I guess list out contracts that are going to fulfill that ERC 4907 standard. So obviously the NFTs that you have right now probably don't fulfill that standard given it's completely new. So part of this marketplace is actually to also offer a separate tab that allows users to mint an NFT that fulfills that standard. The way Double Protocol does it is they have a wrapper contract for non-compliant um, NFTs. We will not be writing a wrapper contract as part of this marketplace. It's a pretty basic one. So yeah, that's the first step we're going to do. So in order to copy it, we're going to pull up our code from episode 2. I think this is rentable NFT. So pretty standard, the same. So I'm just going to copy paste these guys into my contracts. Delete. So was the example from the React box. Copy over the migrations. I'm going to delete this. Copy. Is it there? Maybe not. Okay, let me copy this. Oh, I mean, what am I doing? I paste. Whoops. And then, as always, please add tests. We can just go ahead and delete these. I've been writing my tests in JavaScript just because it's really fast for, I guess, demo purposes. But as I mentioned before in previous episodes, if you want to write in TypeScript, you have that ability, as well as Solidity tests. Where's the paste? Did I not copy this? Copy. Is it because I have these highlighted? Paste. Okay, cool. So I guess the idea with the rentable pets is if you had created your own NFT collection. In this case, actually, what we want to do is make it more generic because we're thinking of a generic ability for our users of the NFT marketplace. So I'm going to go ahead and rename all instances of rentable pets into rentable NFT. So just to do that, rentable NFT place. I think there are also smaller ones. Place. And then just to make sure everything's working, I'm going to just run a simple truffle test. So in order to do that, we'll need to go into our truffle uh, folder since we need to interact with that config, and then just run a truffle test. Oh, I forgot to import my stuff that needs to be imported. So that's the Open Zeppelin contracts, app and contracts. And then also the Open Zeppelin test helpers here. Okay. I think this is a dev dependency, so we don't want to put it in normal packages. Loading. I guess while we're waiting, we can just go ahead and just add the marketplace contract because you can do that. Marketplace. That's sold. Okay, cool. So now if we run a truffle test, guys, hopefully this works. Okay, cool. Yeah, everything passes. I mean, there's this compiler error because I just added a random contract that's not in our deployment file. That's fine. Let's actually rename this file as well. NFT. And rename this to rentable NFT. Okay, so if you actually look at this, this is not an error necessarily. This is what do you call it? I'm using the Juan Blanco Solidity, like, what do you call it? I don't know, extension that does this sort of like highlighting and linting for us. I'm getting an error here because I guess since we are in a random kind of folder structure, it can't find that file, so it can't properly lint it. In order to do that, you just need to, what do you call it? Add in some settings to redirect those mappings. So I'm just going to do that really quick so I don't have those red squiggles. Yeah, cool. And so as you can see, I've basically remapped it to where it should be found. So hopefully it's no longer a red squiggle. And it's not. So that's great. Cool. So I'm not going to modify anything in this file yet. We will actually touch on it again a little bit later. So for now, I'm just going to exit out of that. Also, I just want to just briefly touch on here. If you look in client, if you go to source and then where did they get built? Components? App. Never mind. I don't know what I'm doing. We'll talk about that when we get to the front end. I don't need to touch on this now. This is the smart contracts portion. Okay, cool. Now let's actually write the marketplace contract. I'm going to be doing this from the Truffle code, what do you call it? View. So just headed over into here. I'm going to specify specifically that we're only focusing on the smart contracts. And I think everything should be running. Okay, cool. I'm going to go ahead and delete this because we will be using a different Ganesh instance. Why is this not working? Am I in the right folder? No, I'm not. I went to the what do you call it? I went to the wrong Truffle folder. That is our actual Truffle code. So if you guys are interested in open source contributions and making Truffle better, that's the file you would that's the repository you would clone. But we're not doing that. We're doing rental marketplace Truffle. Here we go. Okay, now it should work. Fingers crossed. If not, we'll just move on. It's fine. It's not that important. Yay! Okay, it's there. Woohoo! Great job. Oh, okay. Sorry. I know why I couldn't find the build files because I built them in a test, so it's not being persisted. Um, okay, whatever. We're gonna go back and start on the actual contract. So as I said before, um, what do you call it? Blah blah blah. We are gonna be working on a contract, a rental place contract that does the unlist, rent, and what do you call it? Unlist, list. Oh, and listing method. So the first thing we're gonna do is gonna be writing that marketplace contract. Um, let's go here. We'll open it up. It's completely empty. I should have just done this. Create. So let me just delete this so I can have all the constructor stuff there. I guess I can't delete it from this view. I'm going to create an issue for that. So I can. But anyways, create contract marketplace. And that should have created a marketplace with all of this information. So the first thing we're going to do is actually start with the requisite imports. I'm just going to copy paste from completed code so I don't have to type all of this out. Yeah, so basically, to go over what we're importing, I'm going to step through these things. So, enumerable set is a struct provided by OpenZeppelin that's going to help us construct that data pattern for how we're going to be storing listings in the rental marketplace, which is pretty interesting. I guess the way I've done it, because Solidity does not offer iterations on maps, so we're going to do a workaround. But essentially, enumerable set is what a typical set is. So that's just like a collection of objects where everything is unique. Retrieval, removal, adding of information or objects in there is going to happen in constant time. If you're like actually stepping through of that, that's obviously O of n. There are some caveats to that with unbounded lists that I will talk about. So obviously, gas is something we always need to keep at top of mind. Counters, that's Open Zeppelin's like increment decrement. We'll be needing that for stepping through our enumerable set. I have here IRC 165, 721, and 4907. That's because we will need to be interacting with functions that are coming from those interfaces. And the last piece here is reentrancy guard. I'm not going to talk too much about that, but essentially what you can think of this is one of the vulnerabilities that might happen with payable functions is something called reentrancy attacks. Just kind of brief summary, it's like basically you could keep calling it and then drain all of your money from your wallet. So in order to protect against that, OpenZeppelin has provided a reentrancy guard that allows us to inherit a reentrancy modifier that would prevent this attack. So what that actually looks like is very simple, is reentrancy guard. And so we're done there. Moving forward, we're going to start talking about the variables that we'll be using. So the first piece here is this using syntax. This is basically syntactic sugar for us to actually use the library functions that we will be interacting with from enumerable set and counters. And then moving on, the next piece. In this marketplace, we will be passing in a listing fee. So essentially, the logic goes anytime a user lists an NFT, they pay a fee to the marketplace contract owner. So we need to store that information here. And then the last piece is all of the data structures we need to store listing information. So specifically here in our marketplace, there's two types of contracts, I guess, that you would, well, not two types of contracts, but two concepts of what you can list. So it's either a NFT contract that you would be creating from the dApp interface itself. Otherwise, a contract that you might already have. Note that contract and NFT collection are the same thing. And then in each collection, each NFT has a unique token ID. So the base data structure we have here is mapping that contract address of your collection to the token ID. So basically, for every collection, this token ID has listing information. As I said, these maps are not iterable. The way we will get around this is basically storing the list of keys. So that would be the list of addresses here. And then in this case, the list of tokens per address. And then the last piece then is our actual listing information. So let me bring this down. Listing information is going to have a few concepts. Owner, so it's the owner of the NFT. User, if you remember from the definitions from the interface, IREC 4907, user is going to be who is, I guess, the renter of the NFT. Contract is the NFT contract token ID. The logic in this rental marketplace is we will be charging rental fees per day. So as part of listing it, you need to tell our contract how much it's spent per day. I also have this concept of start date Unix, end date Unix. So this is, as a lister, you can say, I want this NFT to start being rentable from this start date to this end date, and then expires. So I think that's pretty self-explanatory. Again, from the standard, expires is going to be in a Unix timestamp, so seconds. And then obviously we will be emitting several events anytime a transaction happens. Again, this is so in our front end, we can interact with information that has, I guess, happened during the transaction. Cool. Those are all of our variables. Let's actually get rid of this red squiggly line by modifying this guy. So right here, when we deploy our marketplace contract, like I said, we need to store the information of who that owner is. So that's just going to be the message.sender. Okay, why is this? Oh, okay, we don't need public. That's why. Okay, cool. Now let's actually write the listing NFT function. Again, I'm sorry, I'm not going to type all of this out because it's a lot of code. I'm just going to copy paste, but I will step through the highlights of everything that's here. Where is this happening? Why is this? Oh, okay. Here we go. There we go. Cool. So as you notice here, we have another red squiggly line. That is because I have a helper method is rentable NFT. Also going to be copy pasting that. So to step through, what this function does is it sets before it starts, it actually does a bunch of validations so that it doesn't incur any gas costs if it fails because we are doing the transactions after the failures. I hope that makes sense. But the first thing is obviously, like I said, we can only rent ERC 4907 contracts. So I've created a helper method here called isRentableNFT. Basically, it tries to check for that interface ID, whether or not it's supported. So both the NFT as well as the rentable standard. Here, I specifically use the try catch. What do you call it? Try catch syntax in Solidity because obviously we cannot. If the NFT contract also happens to not be the 165, so that's the interface standard, it's going to fail with a different error than what I was hoping for here. So I just want it to return false instead of like reverting because like it's like, oh, this contract is even like can't be cast to a 165. So that's the is rentable function. Next thing is I want to ensure that the only person who can list this NFT is the owner of the NFT. Make sure that whoever's listing it has enough ether to cover the gas. Um, Price per day, like ensuring the dates make sense. And then also checking that the NFT has not already been listed. And so, in order to check that, that's going to our listing map data structure saying for this collection and this token ID, does it exist? If it doesn't exist, the default value for NFT contract is going to be the zero address. Next piece is we're going to transfer over that listing fee to the market owner. So in order to pay it, we have to cast the market owner address as payable and then transfer that listing fee. And then modify our listing map to add that information. So now that we're listing it for this contract at this token ID, the owner is the message sender, zero address, no one's renting it yet, contract, token ID, et cetera, et cetera. Zero is expires because no one is renting it. We are going to increment the number of NFTs that are listed. That's for our map iteration later that I'll talk over, as well as add that key information to our enumeral sets. So specifically adding in the keys of the different contracts that will exist in our rental marketplace, as well as the, what do you call it, NFT contract tokens per token and emitting an event. Okay, cool. So that is the list NFT function. The next thing we're going to do is be able to rent the NFT. So let's hit a rent NFT. Again, just going to quickly touch on this. I didn't mention this in the previous, I guess, when I was explaining list NFT, but what this does is payable makes it a payable function. Non-reentrance is that protection against reentrancy attacks. Anyways, touching on like what's going on in here, we're retrieving the listing that is going to be rented. Note that I'm calling this storage because we're going to be modifying properties in it, and we want to maintain that in the contract. If this was just something that was going to be created and blown away, we'd call this memory instead. But we're not doing that. That's why it's storage. Again, validation. So checking that this has not already been rented. The next piece is checking that your expiration date is, you're not renting it past what the listing owner is okay with. Transferring that rental fee. So this calculation is basically checking the number of days that you'll be renting it. So it's including the start date of today. So that explains the +1. Note that in Solidity interface division divides by 60 by 60 by 24. That will cut off the, integer division rounds down. So if it was the same day, this would have been 0, but we want it to be 1. Doing that multiplication, transferring it. Specifically here, I'm going to be calling that 4907 set user to indicate on the NFT that this NFT has the user and the expiration date. Technically, I guess in this marketplace protocol or contract, you don't need this because we store that information on our listing. However, we do this because of, I guess, interoperability. If anybody else in the entire ecosystem wants to interact with your NFT, they can check that it's a 4907 and check that user property and get that information. And the last piece is emitting an event. So that's rent NFT. This next one is going to be the unlist NFT. Shoop. So again, here, unlisting the NFT. Straightforward again. Listing is storage. Doing some checks here. So checking that it isn't already listed. Or sorry, you cannot unlist an NFT that does not exist. The only people who should be able to unlist an NFT are either the owner of the NFT. I also set it so that the owner of the marketplace contract cannot unlist it. Logic wise, I wanted to say that if you're unlisting it and a rental the user is still renting it, they deserve a refund. And that refund is just going to be the number of days remaining times the price per day. And so that is refunded here. We need to clean up the data afterwards. So resetting that user data so that, there's no more user data on it because it's been unlisted and therefore unrented. Um, and then also changing those, I guess, that data structure. So removing the information from the tokens, deleting that, I guess, structure from the listing map. And then in the case that, for this NFT, if we have deleted all of the tokens associated with that NFT contract, then we will also be removing that NFT contract from the list of NFT contracts. Finally, we are decrementing NFT listed because we have unlisted an NFT. That's the unlist function. Um, the last, I guess, like functional function for our interface is going to be the get all listings. So this is, hmm, oh, okay. This is why. Hopefully, why is this not working? Oh, that's why. Okay, here we go. Cool. There are some caveats that we need to think about when using this data set. Um, So specifically, I called out that we are using a enumerable set. The way we are listing, or I guess the way this function works specifically is we will be iterating through every single contract. For each contract, and we will iterate over the token ID and then aggregate that listing function. One thing to note that is if these lists get incredibly long, it could potentially occur like really high transaction costs because of all of the overhead in storage, or sorry, in memory and like computational costs. So this is just a simple tutorial. I'm not really thinking about that kind of future case. So that's why I'm doing it this way. But if you are gonna be, I don't know, using this in production, kind of give like maybe not the best way to do it. Obviously, you should do some processing probably off chain. Instead, I am hoping to invite like a subject matter expert to talk about gas optimizations and like workarounds and best practices. So keep an eye out for that. I do also want to note here specifically, get all listing returns all listings regardless of whether or not it's expired or it's even like within the rental period. Um, you could write separate functions to get that information and do the filtering in Solidity. But obviously, again, like I said, computational costs, you don't want to incur those. That kind of stuff should be done off chain. So we would be doing that filtering inside the front end portion when we write it. So that's get all listings. And then the very last piece, actually, that I'm going to add is just like a little helper function to get the listing fee. This is specifically for testing purposes. So I can use it in my tests, just returns the listing fee. Oh, that's marketplace.sol. Um, Last piece is going to be, well, I guess like two things, right? So um, one thing I want to note is in set user, if you guys remember, the way we implemented it was that the only person who can set the user on this NFT is either approved to do so or the owner of the token ID. Um, how do we guarantee this? Well, I mean, you would have to call NFT.approve, but specifically to backtrack, uh, if the logic I want to implement is if you are minting an NFT using the provided rentable NFT, I want to just go ahead and give the marketplace contract approval to interact with it. So, in order to do that, I actually want to pass in the marketplace address to rentable NFT to set approval for all during the minting function. So to do that, instead, we need to give the constructor an argument. So that's just going to be address uh, marketplace And then this is going to be address private marketplace. Cool. Then all you do is say marketplace equals marketplace. And that's how you get that information. And then when we mint it, we want to set approval for all. So I think, oh, this is a private function. Let's just go ahead and do this set approval for all. The owner is going to be message.sender. And then, or sorry, person who's going to be approved is the marketplace. Contract approved will be true. Cool. So that's how we've modified rentable NFT. Now let's actually dive into modifying our config so that our marketplace contract will be, sorry, not our config, our our deployment file. So this is going to be deploy contracts. So we need to do this with marketplace. Cool. And okay, so what's special here is that we need to ensure that the marketplace contract is deployed before rentable NFT. In order to do this, we can use an async, make our deployment function asynchronous so that we can use the await syntax. So that's basically saying await marketplace equals, how does it go? Oh, sorry. We're going to await deployer.deploy marketplace. Now we're going to say the marketplace is going to be that deployed marketplace. And when we deploy the rentable NFT, then in order to pass in contract functions or contract constructor parameters, this is where it goes. So dot address. Cool. So I think that's all we need to do before we start writing tests. So to write a test, let's just do a Truffle create test, test marketplace. And let's open that up. So again, this is an incredibly long file. I'm going to just go ahead and copy paste everything and then we'll walk through it. So the way I have this test set up is essentially before, I guess, we start writing all the tests, we're going to mint a few NFTs in order to interact with them throughout all of our tests. Have that marketplace contract, rentable NFT contract to interact with the listing fee. So this was like the helper method that I had created. I also set up some constants here. So I'm saying the first account is going to be our marketplace owner. The token owner, so basically, if you look in our test, anytime I mint an NFT, the token owner is going to be that address. User, that's going to be my constant address for whoever's going to be the renter. So yeah, the other piece I do want to notice, call out in this file as well, is I actually have a bunch of test helper methods. So obviously, if you're writing good code, don't duplicate it. In this test, there's a lot of assertions that are always going to be asserting either the listing properties. So I wrote a helper method for that. I also wrote an assert NFT function. So this is specifically checking that the NFT has that proper 4907 user information set on top of it. Get listing. So this is a helper method to get the correct listing according to token ID. This is specifically because when we construct get all listings using that enumerable set, the order of it is not guaranteed. So we can't predictably say like, oh, if we listed this second, we can be comparing against the second listing. We should be matching that according to token ID. And then the last piece here, listing to string. So I'm using an expect event helper method from OpenZeppelin. Essentially, this allows us to assert that events are happening. With events, that data that is stored on it is going to be all represented by strings. So this just converts that listing from, for example, an integer over into a string. So those are the helper methods. And then I guess starting here at the top two as well, more constants, just to help with making the test more readable. So moving forward, should list NFTs. So the way the test steps through is basically it lists it, it checks the validations against it, it then rents them, and then validates the rentals, and then unlist them and do the validation. So just gonna start from the top here, validating. Not this. It's this one right here. Should list NFTs. So things I want to call out in this function specifically is I'm using this concept of a tracker. So with OpenZeppelin, they also have another test helper utility called Tracker. Essentially, what this allows us to do is track the balance of a particular address account. I do this because I want to assert, if you see, where is it here, that the listing fees or the refunds or the rental fees are properly transferred. In order to do this, I need to get the balance before and after the listing. While you could be doing this with like just a web3.eth.get balance, I think this kind of subtraction math gets a little weird because since all of these the balance is listed in way, that number gets really, 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 really long, and could overflow. And so JavaScript has to wrap those things in a concept of big number. So tracker.delta does all of that magic for you. So we don't need to worry about like big number casting or anything of that. Here we're expecting a listing to just have empty information, asserting that it's happening, it is correct, the event is proper. I list a second NFT here as well, to make sure, if we get the second token ID, changing that information, it is properly persisted. Now that things have been listed, just going through our expect revert, that's an OpenZeppelin test helper method. So stepping through all of the different properties that will make this function fail. Next part is rental. So again, here asserting beforehand that yes, indeed, these have not been rented because the user address expires as 0. Again, using that tracker concept. Before and after the rental is expecting that the delta, so how much that balance the token owner has before and afterwards, is equal to the expected amount. So in this particular case, the listing price I had before was 1 ETH a day. So the price per day times 1 day, because it's rented on this, it expires the same day, is 1. So that should be 1 equals 1. Again, asserting that the listings are correct and have been updated with that user information. Same with the NFT. And then again, here, I'm doing another test. If I rent it, I think when I listed this, it was 0.5 ETH. And so 0.5 ETH over 5 days is 2.5. And so I expect that to be true. And then again here, validating all of our expect reverts. If you notice here, I actually add a third list NFT. This is because in the first case, both mint token 1 and token 2 have already been rented. So I need a third one that will be unrented so that I can test the extra validations. I guess I went ahead and did the unlisting here. So again, NFT is not listed, not approved to unlist NFT, not enough ether to cover refund. And the last piece is the unlisting function. Again, using that tracker to test the balance difference before and after unlisting, as in the user of the NFT should have gotten a refund, and that, everything's been unlisted. And so that is the test. And if everything works, then I should just be able to run a truffle test. Fingers crossed, fingers crossed. Everything works. Yay! Okay, cool. So that's actually the marketplace contract. Everything works. I did mention in the agenda, we're actually going to write some scripts and then also interact with a rentable pets contract that we had deployed before. So this is like pretty cool. Um, let's go ahead and jump back into our rentable NFT. So in order to interact with an existing NFT contract, when we write that script, there's this concept of like creating a contract from the ABI. So, creating a contract listing all of the methods that you expect to be on it with the contract address. And then Web3 will go and query that information and pull it down. In order to get that information, we need to verify that contract. So, verification is basically like telling Etherscan that this contract is real and uploading that source code information. So we have a pretty nifty, I guess, plugin function that will help you do this verification through the command line written by like Roscoe Callis. I'm not sure how to pronounce his name. But to do that, essentially, first thing we need to do is actually deploy our contract to Girly so that it could be used across both the marketplace and our actual collection. So to do that, I'm going to go into here. We're going to need our Infura account. So to go to Infura, we'll go to my dashboard, create an account. I already have one here for rental marketplace. So if you go to manage keys, pull out this one. This is what we'll be interacting with. Um, Here, I'm going to go ahead and pin this. I'm going to be using Truffle dashboards, which allows me to deploy without exposing my MetaMask. So I'm going to add this to my MetaMask account. I already have, but the way you would do it is just add that network and then like the network URL here, Girly Dev, blah, blah, blah. To show you what I already have for Girly Dev, the chain ID for Girly is 5. That ETH information is there. When you fill this out, you might get like a user error saying chain ID is already there. That's because we also give you a default Girly address. You can ignore that. It's fine. So yeah, I've added it to our MetaMask. So now if we go back to Unleashed Rentable NFT, we're going to deploy this to the Girly testnet. So in order to do that, let's just do a truffle migrate. Dashboard. So I have already brought up dashboard. In order to do that, you just do a truffle dashboard, and it pulls up this view right here. It's so beautiful. The newest one has dark mode too, but I'm a light mode person. Um, anyways, back to what's important. Where are we? I need to migrate it to Girly. So going back here, migrate truffle migrate network dashboard. So this should compile it. And what's wrong? I could not connect. Am I not in a... Okay, well, sorry. First thing I want to note actually is with Truffle plugin verify, there are some issues with verifying a contract where it imports things from node modules like here. So we actually have to change this path by copying over the necessary contracts from node modules over into actual contracts. I've already done this in a separate branch, so I'm just going to git checkout verify contract. So as you can see here, I've actually imported copied over the relevant contracts, changed these files. So we need to deploy that now. Hopefully this works. I don't know why it didn't before. Dang. Please connect to... I thought I changed it to dashboard. Truffle dashboard is running. Maybe it wasn't running. I don't know. Okay, we could just try again. Confirm. Make sure that Girly Dev is what we have here. Cool. and then unleashed rentable NFT. Let's open up a new one. New terminal. Truffle migrate network dashboard. Okay, cool. Yeah, I guess I just actually didn't have dashboard running. Where is this? Here we go. Okay. As you can see here, it is asking us to deploy. I'm just going to hit a confirm and it should have deployed. This takes some time because it is the Gurley testnet. So we are not doing it on Lightning Fast Ganesh. So that is done. The last piece now is to actually do the verification. So to do that, we need to follow the Truffle, what do you call it? Truffle plugin verify docs. So let's install that. And so you can specify plugins here in our Truffle config. Just go ahead and go down to the bottom. Oh, I already have it. Nice. Oh, yes, because I did this in a branch. I forgot. But anyway, so you add in the plugin here, so that's how you define it. To submit that information to Etherscan, you will need to go to Etherscan and get an API key. I specifically here put my API key in a .m file so I don't commit it. So I recommend that you do the same. And also add that to your git ignore so you don't commit that to GitHub. But anyways, so I have it here. Nice. Good job, Emily. Um, yeah, so actually I should be able to just run Truffle plugin verify, I believe. So verify, and I can still use dashboard again. If you don't want to use dashboard or like some other network specified in your config, you can do that as well. And so it should verify rentable pets. This takes some time, so I'm actually going to hop over to Etherscan now to show you what it looks like when it's verified. So let's go here. And this is taking some time. So I'm just going to start writing the scripts while we wait. Start a new terminal. So just to briefly touch on what scripts are basically allowing you to run Truffle scripts on the fly. This can be for really fast testing if you want to populate actual information. In order to do that, we need to write, that's done via Truffle exec scripts. So let's create this one right here. This is really nifty because you can actually make like your own CLI if you wanted to. I'm not going to do that because this is a simple test and I wrote all of this in less than a week. Okay, where was I? I was writing the scripts. So the first thing we're going to do is I'm going to create 4 scripts. So touch scripts, one for listing, one for renting, and run for unlisting. Did it finish verifying? Yes. Okay, cool. It finished verifying. So let's actually go to Etherscan. And you can see this contract. So after that's been created, you can actually see that when it's verified on Etherscan, it has all the source code there, the interface, and all this information, which is really nifty. And the ABI is here as well. And so this allows us to, I guess, talk to this contract that's already been deployed. Fancy, fancy. Cool. Now that it's also deployed, we want to actually mint an NFT that we will be interacting with. So we want this all to be on Gurley as well. So I'm just going to quickly mint one on Gurley. So Truffle dashboard, let RP equals await rentable pets dot deployed. rp, oh wait, rp.mint. Just URI. And if we go back to dashboard, we are going to mint, confirm. And so all of that should be there. Just going to have this set up here on Etherscan so we can view it. Okay, cool. So that's been minted. Coolio Boolio right here. So that's all the verification part. Let's actually move on to writing our scripts and interacting with this already deployed NFT. So I'm just going to exit out of this. First thing we're going to do is modify that list script. So let me copy paste that guy here. Cool. So this is the listing script, I believe. So to step over the important parts here, I am passing in the NFT. To get the NFT contract collection, we pass in the ABI. There's a lot of functions on this contract. I'm only using owner of as well as approve. So I've only pulled out that information from the ABI. And then the NFT contract is going to be the address of the NFT we deployed. So let's actually go to this guy. Okay, cool. I think there are better ways to click into this, but that's fine. Contract address. Let's fill this in here. And essentially what it does, it's going to first off, get that contract, get who the owner is. And I want this specifically for two reasons. First off, it's to approve the address that it is allowed to call that set user function. So that's not part of the contract, but you can imagine that that is something we would add in our front end DApp before someone lists it, requesting the user to make this approval. And then listing the NFT with all the appropriate information. So to actually run this, I don't want to do all of this on actual Girly because that is slow and it takes real money. One thing we can do is actually something called Ganache forking. So that's going to bring all of the information from, I guess, testnet, mainnet, whatever you want it to be, locally. And also has like a lot of really neat configurations on it as well. And so in order to do that, I would call a Ganache. I specifically want to fork the information from Girly. So where's my Infura thing? Right here. Fork URL. That guy's here. And one more thing that is really cool that I think is really important, or actually two more things. So we want to fork up from the Genesis block up until this block number, which we can go to Etherscan. The latest thing that we care about was mint, so we're just going to grab this block number. We only want to copy all of this data. And the last piece actually is this thing called wallet.unlock. So unlocked accounts. -u is the shorthand version. This is a function that basically allows you to act as an address without having to use it, knowing its private keys. So specifically, it's because here we need to be able to do the approval as owner. Obviously, I don't have that address within my local Ganache instance. I don't have its private keys, but -u allows us to basically use it as we wish. In this case, I deployed it using my own MetaMask wallet. So let's just go here and copy paste this. Everything works. It is up and running. So I think, did this run on, where does it say it ran on? 8545. Oh, here we go. So we actually need to go to our Truffle config. Truffle config, and I'm going to add a network. So Girly dev is what I'm going to call it. And this is for our local Ganache instance. The host is going to be 127.0.0.1. The port here is going to be 8545. Network ID is whatever. It doesn't matter. Cool. And so if we go here, now we can actually interact with it. So let's just go into Truffle console network. Okay, well, so there's like two ways of execing a script. You can just do a Truffle exec scripts and then network. I'm going to do everything in the console because I'll be, I guess, executing a couple scripts. Network girly dev. Cool. So now I'm able to actually interact with my Ganache blockchain. First thing we need to do is migrate our contracts. Hopefully that works. Yep. And then all I need to do is exec script / list.js. And it listed. I expect if I try to list it again, it'll fail with that revert function or that require statement. So we're good to go. Next piece is the rental function or rental script. So let me copy paste that over. Again, very straightforward. Let's use the correct NFT contract here. One thing to note in particular that's special. Is there anything special here that I want to call out? Nothing particularly interesting. I guess we get the user by getting the accounts. If you guys don't know how to do that with Web3.js, that's how you do it. Renting the NFT. So if I do rent.js, work. Cool. And it does. And if I run it again, it's already been rented. Nice. Unlist JS. Where here we go. Oh, actually, one thing I did want to call out in rent.js, it's not here specifically, but if you remember, like I said, rent.js does set that user. Because I had done this approval in the list portion of giving that marketplace address approval, this does not fail. Had I not done this, this would have failed with like a marketplace is not approved to set the user or something like that. So keep that in mind. Okay, last piece, unlist.js. Cool. So let's go here. I need that contract again. And then the ABI here, we care about two things, user expires, and we are also caring about the owner of function. So that's the ABI methods that we're pulling in. Getting that information here, expires. So this is just to calculate the expiration stuff on the fly, and then do the unlist. I expect this to fail, but that's because I want to show you something cool. So if you notice, it says not enough ether to cover the refund. I think in this script, the amount of ether that we would be returning or need to cover the refund is 1 ETH. If you remember, my wallet is actually only populated with like 0.3755, so that's not enough to cover it. However, because we are in a local Ganache instance, we can set that amount of ETH to whatever we want. So this is actually one of the nice things about creating, what do you call it? Creating scripts is it doesn't have to necessarily interact with your contract, right? It could just be like whatever you think is a nice helper. So let's create a new file. I'm going to call this load.js. We're going to copy paste this. So essentially what this happens is whenever I call load.js, it's going to just send this EVM set count balance, which is just going to set the amount of ETH. This is the amount this is like what 1000 ETH would look like in hex. And then I'm just going to get that account information here. And so if I do a load.js, I've added 1000 ETH. I am super rich, guys. And now if I run unlist, I should have enough ETH to cover the unlisting. And it does. And it works. And I think that's everything. Wow, this is the first time I haven't gotten 30 minutes over. We're only 5 minutes over time. So yeah, now I guess I will jump into the end, just kind of talk about what's coming up next. So, like I said, this was just part one. So part two will be coming up next at some point when I write the front end. But next week specifically, I will be in Berlin at DAppCon, which will be pretty exciting because I'll be hanging out with Hilmar from Gelato Network. He's the co-founder. Gelato basically does smart contract automation. We'll be talking about, what it is, how to do it. I think there's a lot of really creative ways if you guys were interested in actually integrating smart contract automation into your marketplace project. So, I mean, some things you could think about is like checking like nightly or whatever if like something has expired and you want to rent it. Um, that's actually also something that EPNS could help us with. So EPNS is Ethereum push notification service. So when we talk to them, just talking about sending like Web3 notifications to users. After that is decentralized streaming with LivePeer, with Yandan Fu, one of the co-founders of LivePeer, building a bridge with Optimism, MetaMask API. There's a big backlog, guys. So if there's anything you want to see, um, throw it on our discussions, Discord. I publicize all this information on our GitHub repository. Um, and yeah, cool. So just starting off again with like a big thank you. Follow me on Twitter, follow Truffle if you want the latest information. As these guides come out, if there's like follow-up material to be sent out, please sign up through our type form and hand us your email. We'll send out reminders for like when our next episode is going to be. And yeah, now it's time for questions. I hope this stream didn't like break in the middle of anything, but we will find out. Chat. Okay, I think all we have is good vibes. I think there is a delay between my load and the actual stream, maybe. So, or not. If there's no questions, then I'm just gonna end here. Thank you guys for joining. If you were watching on LinkedIn, I don't have those comments coming in, so I guess comment them from YouTube or Twitter. Otherwise, this is the rental marketplace, guys. I hope you had a really good time and you learned something new. I definitely learned a lot. And see you next week with Gelato Network. Cool. Bye.